Hey, welcome everyone. Good morning, good afternoon, good evening from wherever you are joining us. Welcome. Today I'm joined by Nathan Heston. Hello, Nathan.
Good morning, Daniel.
Hi. So today we're really excited to have you with us. We're going to be talking about integrating generators and energy storage systems. This is a NABCEP accredited course, so we are going to be offering credits. At the end of this webinar, we're going to have our email is going to pop up. So please email us with your full name, spell it out for us so we get the name correct on the certificate, and then we'll go ahead and issue you the credits. Well, with that, let's go ahead and get started. We're really quickly going to introduce some of our companies. We're going to talk about what's driving the market, why we should combine generators and energy storage systems together, a little bit about our product overview, and then again, we're going to talk about some future training opportunities, and then as well, how to get the NABCEP credits for this course. So a couple of upcoming exciting events. One of them is going to be the Oregon Solar and Storage Association up in Portland. Nathan, you're going to be there, right?
Yeah, I'm going to be there and I'll be leading a training on whole home backup featuring Solar 15K as well as our batteries. And I'm excited to be going. It's going to be my first time up there at OSEA. Daniel, you're heading to HISEA, right?
That's right. So in Honolulu, coming up again, both of these are at the end of this month. We're going to be doing a talk. I'm going to be giving 3 talks, the introduction to our products, definitely talking a little bit about how to leverage communications between our batteries and solar converters. We're going to talk about programming and some of the optimal set points for that. Then round out the day with a training on off-grid living, which is not necessarily the biggest thing in our industry, but it's definitely something that is still a market and really, in a lot of ways, was how this industry got its start. So if anybody is interested in these, please let us know. We'll be happy to meet with you when you're out there.
And as we get started, I want to point out to everybody that we do have a Q&A session. So if you have questions as Daniel runs through this training, feel free to pop those questions into the Q&A. And at times I'll answer them, and at times I'll stop Daniel and have him answer those questions on the fly. So
Yeah.
Go ahead and use that Q&A. Welcome, everyone.
Yeah, thank you, Nathan. I would argue that Briggs Stratton Energy Solutions is one of the best companies in the industry for generators and energy storage systems. Why? Because we make both of them. Briggs Stratton has been around for a long time, over a century-old company. And historically, we've been in engines and generators as well. And we were recently able to join into the energy solutions portfolio, Simplify Power. And so Simplify Power is brought into the Briggs & Stratton family, and now we can offer those energy storage batteries. We've always leveraged lithium iron phosphate chemistry and had a really kind of knack for quality as well. So we're able to provide both of those, and we're going to jump into a little bit of how these two systems combine as well. So as you see down in the right-hand corner, our generators and our batteries. And then you can also see we truly do have a global reach. And so really excited to be part of Briggs & Stratton. And I hope you join us in our products. And we really hear an American company that can provide you that service. Another exciting partnership we've been kind of going into is with Solarc. And I would also argue that Solarc is one of the best inverters on the market for generator integrations. And we're going to explain why here coming up. One of the main reasons is that they have that gen port, the generator input. Also, additionally, all of the things are built into that Solarc. So our charge controllers, our automatic generator start, the rapid shutdown, the inverter charger, it's all in one kind of part and piece. So it's no longer back in the old school days where we'd have all these different parts and pieces. You hang one piece of equipment on the wall, put the energy storage systems next to them, got the generator sitting outside, combine them all to a home to give them that backup resiliency. But also additionally, there's a lot of other opportunities such as being able to do grid arbitrage, time of use. And again, we get more into those in some of our other trainings, but definitely we'll touch on them slightly here.
So Daniel, as you just pointed out, that Solarc is one of the best inverters on the market to integrate generators with. And, I want to point out that systems like the new Powerwall 3 can't do that, right? And when you are doing more complex systems, when you have generator integration, when you might have an automatic transfer switch that's included, when you might have AC coupled solar, software is really important, and Solarc has gotten their software right, and it eliminates those service runs for the generator not behaving as you expect it, because the two wires start from the inverter is not working well because of poor software design. Solarc has great software, and that's one of the reasons we recommend it for use with our batteries and our generators in energy storage systems.
Yeah, thank you, Nathan. Great point. Software is definitely becoming more and more important in this industry every day. One opportunity for anybody on this call, we do have an IQ installer program. So if you currently are installing energy storage products, please consider joining. We're going to give you $1,000 off your first install, plus $300 if you buy a stack of 3. So $100 for every battery module you buy. That's going to be indefinite as far as I can see, at least until next year. But $1,000 off your first install. So go ahead and scan your that QR code on your screen, or go ahead and email us down at the bottom for the sales team. Really excited to have you on. In addition to this money, we'll put you on our locator maps. We'll send you some swag, some shirts, some hats, some gloves. Really excited to have you be part of this. And if you have any questions, put it into Q&A about the program, and Nathan and I will address them. So this talk is going to primarily focus on adding a generator to an energy storage system. But unlike a generator, which kind of just sits there as standby kind of backup power, an energy storage system can also provide utility bill savings, right? I talked a little bit about doing time of use rates. Also be able to do peak shaving if that's something that's in your jurisdiction. And then also be able to tie in some of that renewables, right? So we think about a generator and you got a propane tank. Well, you need a propane truck, or you got to have a natural gas, whereas solar or even wind, which Solarcs are capable of bringing in, it's essentially going to be able to refill your fuel tank for free after you've purchased the products as well. Off-grid historically has always leveraged generators. Why? Because if you live in an off-grid community or an off-grid house, and I size your solar to get you through the dead of winter, the solar is going to be way oversized for summer. So a lot of times we find a balance, and we're going to integrate a generator into that system so that during a winter storm, when it's been cloudy for 4 or 5 days, we can start up that generator and recharge those batteries and then shut it off. So I've always historically seen generators in off-grid situations. Now what's interesting is we're starting to see generators be tied into on-grid systems to give the homeowners or the business owners that extra level of resiliency. And awesome, we're going to be talking about generator optimization as well. So historically, how we've always done a generator, really, we have that meter socket, we have that meter can, and usually there's a disconnect there as well. We bring it into an automatic transfer switch, and then if the grid goes down, that automatic transfer switch is going to see the generator start. It's going to transfer over to generator, and we're going to support the entire load of the home on that generator. When we add a generator into an energy storage system, it's pretty similar, right? We still have our meter can, the meter socket. We're going to have a disconnect in there as well. But now, especially with the advent of much larger, more powerful inverters like the Solarc 15K, that's able to take all 200 amps in from the grid, we're able to use the Solarc as the transfer switch. So we're still feeding grid into that Solarc, 200 amps right back out to that load panel. If grid goes down, that Solarc within 5 milliseconds, and Nathan, correct me if I've got that wrong, is going to automatically recognize grid has gone down, isolate you from the grid, and start powering those backed up loads, or maybe potentially the entire load of the home on energy storage on the batteries. If it detects, the Solarc detects that the energy storage batteries are starting to be drained, we can go ahead and program certain set points. We're going to show you how to set those points up here in a minute to start up that generator, charge up the batteries, support the home loads, and then shut that generator off once we've reached a certain threshold on the battery level. So very similar, but a little bit different. I just wanted to demonstrate that here on this slide. A lot of times when we're dealing with generator installers or maybe even homeowners, I think generator installers understand power, right? When we go to look at a home and we're sizing a generator for a home, we look at the square foot of the house, We add 3 VA per square foot. We look at some of the larger home loads, and we look at some of those kitchen circuits, and then we come up with how many watts or how many kilowatts does a generator need to be in order to support that home. Maybe a 22K generator, maybe a 13K generator. One thing, though, when we add energy storage, we need to start thinking about energy or how much fuel is in the tank, and that's measured in kilowatt hours. So a lot of times, just to break it a little bit simple, we're going to think of the inverter as kind of the engine in a generator, and we're going to think of the battery as the fuel tank of the system as well. Nathan, anything to add to this?
No, I think that that's a pretty good description, Daniel, of what you're looking at and how this comparison works out.
Thank you. So really quickly, if we think about why somebody would go with a generator or an energy storage system, the differences, right? So in a generator may be less expensive on the upfront, but that's not always necessarily true anymore, especially with that 30% tax credit available on energy storage only. Generator is probably going to have more of an unlimited source of fuel with a large propane tank or a natural gas line. A generator may be able to support more home loads. I would argue against that a little bit with some of these advent of some of these larger inverters that are coming to market where we can back up the entire home loads. If you do go into one of our generators and you look at the histogram or the rate at which the load of the generator has been run at, a lot of times, even though we put a 22K generator on your house, most of the time the generator is only running at 2,000 watts or 3,000 watts to support kind of the base loads of the house. The reason we size them much larger is to start motor loads. Well, with an
Daniel,
energy,
I've
yeah,
got a
go
quick
ahead.
comment on that, and I think that's great. So one of the questions we often get is, hey, can I, cost is obviously a factor, right? So can I install an inverter with a battery system and then use a smaller portable generator?
Yeah, absolutely. A couple considerations with portable generators is that they do have to be 240 volt in order to feed it into that solar. You're going to lose the capability of that automatic generator start. So you are going to have to kind of be closely monitoring that great app that a lot of the inverter companies have, including Solar, to know when to start up that portable generator. So absolutely, you can.
So another comment, Daniel, here on this is, when we're looking at using an inverter system, you mentioned, total inrush current for, locked rotor amps for compressors, for example. A very common one is an air conditioner. I was just watching a video recently with Engineer 775 in which he put one of these soft starts on, and we went from 126 locked rotor amps on a 3.5 ton air conditioner down to 26 by adding a soft start, right? So there are ways to make large air conditioners reduce their inrush current for that startup cycle. And these parts are generally relatively cheap, so you can certainly back up a whole home. Another comment we often get is, hey, what's the average amount of power that a typical home uses, right? And I've said in previous videos, right, the 24-hour 365 average for the United States is 1,200 watts. 1,200, not 12,000, right? And so when we're putting a 26K generator on there, to your point, often it's only drawing a couple thousand watts, 1,200 watts for the average home. Now, granted, it goes up and down depending on, the season and depending on time of day. Draw during the day is high, night is lower. But I think you're going to address some of this with why it might make sense to only have that generator on when you want it.
Yeah, great point. And also, speaking of HVACs, that's usually one of the largest loads on a home, the heating and cooling of your home. A lot of the newer HVAC systems, especially these mini split or heat pump ducted systems as well, have inverter-driven compressors. So they're much lower startup draws than you would typically see on that old clunky air conditioner that you got on the side of the house. That still, like you mentioned, Nathan, can be added with a soft start as well. With the generator, right, it's just sitting there waiting for an outage. With an energy storage system, it can be, I would like to call it that grid interactive appliance, which can accommodate time of use. If you are in certain jurisdictions that don't have net metering, where it doesn't make sense to send solar back to the grid anymore, because you're not getting that one-to-one credit. Let's store that energy in the batteries and then discharge it at night for the home loads as well. But when we combine a generator and an energy storage system and we're off grid in a storm, right, what we can do is add that extra level of energy resiliency. We can run the generator at a relatively high load, right? So we're going to run the generator hard, run it at its most fuel efficient point, and then shut that generator off. It saves fuel, which can be hard to get in a crisis. And as I mentioned, right, the generator is going to support the loads and charge the battery when it's running. You reduce the fuel. I did kind of was hinting at it, right? So although a generator sometimes can be less expensive up front, when you start to look at the price of propane, which could be $2 or $3 a gallon, and one of these generators might use 2 gallons an hour, that fuel cost starts to add up, maintenance on that, and frankly, the noise as well. So always make sure you got the exhaust pointed towards your neighbor's house and not towards your bedroom window as well. So we're going to talk a little bit. There's 2 fundamental ways you can integrate a generator into a solar arc specifically. But a lot of the other hybrid inverters, some of these concepts may apply. And one of the first ways we're going to do is talk about how to bring in the generator on the gen port. So really quickly, I want to just kind of show you what the inside of a Solar Arc 15K generator looks like. On the left-hand side, we have our DC breakers. What's really cool about that Solar Arc 15K is that we have dual battery inputs, which means that if you're going to have a single stack of our batteries, great, you can bring them in. And if you have 2 stacks of batteries, this is awesome because this avoids having to buy a Midnight Solar combiner or Blue Sea Systems or a Victron combiner. You can bring in both of the stacks of batteries onto these dual lugs and be able to combine them without having to buy an extra piece of equipment. As we move over to the center of our screen, we see those kind of the parallel comms. That's if you have multiple inverters. We have our battery CAN bus, which is where we're going to plug in the batteries to the Solar Arc so that the closed loop communications, the battery can talk to the inverter, listen to what the battery is telling its temperature, its health. Accessory pinouts, we're going to jump into that a little bit more here, but that's where you're going to wire your rapid shutdown capabilities, the e-stop button, the automatic generator start. Below that is where we land our solar. It's really nice to have those 3 MPPTs built in, and additionally to be able to parallel up strings, maybe save you having to buy some Y connectors. Now we move over to the ports, right? So this is where the gen port, which is on the far left, is where we're going to land our generator. Or we could pull in AC coupled solar, or we could use it for a smart loads output. We're going to get into a little bit more advanced designs here in a minute where maybe you do have AC coupled solar and you want to bring a generator into the system. Historically, this has been difficult, but what's awesome about Solar Arc is that there is some ways to do that, leveraging some of our Briggs Stratton products. In the center is our loads output. That's rated 200 amps. On the far right-hand side is our grid input. The 200 amp, that's we got a typo there, Nathan. That's technically not a breaker. That's just a load disconnect. So you are going to still want to see a breaker on the load panel where you're going to have your home distribution as well. Load out.
That is correct. I mean, you will have your overcurrent protection built into the Solar Arc software, but to meet code requirements on wiring, you need to have that breaker there.
Yep. Thank you. The grounding bar and the neutral bar down there at the bottom as well. And I like that they have kind of a lot of space down there at the bottom and make some of these connections pretty easy. So the first way we're going to talk about it, and I think this is probably going to be one of the most common ways we're going to pull a generator into a Solar Arc or a lot of the other hybrid inverters, is on the gen port. So at the top right, we have our grid, our meter can. We're going to have our disconnect feeding into the grid. We can bring all 200 amps in, 200 amps right back out on that load port into our load distribution panel. We're going to land.
I'd like to bring in a quick question before we move too far along. Kevin writes, does Briggs & Stratton provide energy calculation software to calculate the smallest generator needed when using battery and or solar? Obviously, there are many variations on how to compile your system. Software would help establish this.
Yeah, I think one of the nice things about a lot of these hybrid inverters, including the Solar Arc, is that we don't want to overload the generator, right? We want to be able to program that generator so that the Solar Arc to not exceed the capabilities of the generator. So aside from the sizing considerations and what loads we might be expect, which I think would be, we do have the calculators available and we have sales application engineers to help you out. We want to make sure that we don't overload that generator. And Nathan, anything to add to that?
Well, I guess I would say, yeah, I'm not super familiar with our calculators, Kevin, so I apologize. I'm not knowing more about what generator calculators we do have available. I will tell you that there are options when you are setting up the Solar to provide priority to where that generator power goes. So you can choose to first cover the loads, and then if there's additional power available to then cover battery charging, you can set an overall limit on how much power the Solar will pull from the generator port altogether. And you can let the Solar know whether you're coupling the generator to the utility port or to the gen port, as Daniel is showing in these couple of slides. So honestly, as long as you have a 240 volt generator, you can really make it work with the Solarc software with most sizes. So you can go fairly small, but again, if your batteries are getting low and you're going to want to back up the whole home, when solar is not available, then you're going to want that generator to be able to cover the whole home. So keep that in mind, that you can't go too small if you need to cover the loads of the house. So I don't know that I've answered your question, but we will try to get back to you if you send us an email, energystoragetraining@basco.com. That's BASCO.com, BriggsandStrattonCompany.com. We will provide resources and links to those calculators. We'll also have an email coming out tomorrow with this slide deck, and I'll try to get those links in there for the calculators we have available. So great question. Thank you. We'll try to get that information to you.
Yeah, and we're going to show you here on an upcoming slide exactly how to program that value so you don't overload the generator. One nice thing about this is that there's no transfer switch. As I mentioned, the transfer switch is built into the Solarc, so we're not needing that extra piece of equipment. If you do come out to a site that already has an existing transfer switch, we're going to show you here in a little bit how that might look. So when we look at that accessory pinout, one of the ones we're going to focus on here in this talk is how to wire up that automatic generator start. And so we do have a normally open two-wire signal on our Briggs & Stratton Energy Solutions generators. So that on the Solarc side, it's going to be pins 7 and 8. That's what we're going to run over to our generator and then be able to start up that generator as well. There's a lot of other ones here. We cover these more in depth in other talks. Definitely don't use the battery temperature. The CTs, although the CTs are built in the Solarc, it's best practice always to add your CTs. B and B are your emergency stop. And then 15 and 16 are going to be for your rapid shutdown transmitter, for your Tigos, for your AP Smart System rapid shutdown systems up on the roof as well. So now what we've done is we're taking a look at a picture of inside of our generator wiring bay. And so out of pin 7 and 8 on the Solarc, you're going to land your two-wire signal to start on pins 4 and 5 inside of the generator. So on the left is one of our horizontal units. That's our 18, 20, 22, and 26K generators. And on the right is our vertical 13K generator. So this is what it's going to look like when you kind of jump into there and look at where you want to land inside the generator as well.
I want to point out, Daniel, that although we're showing this with our generator, certainly the Solarc with our batteries will also work with other generators. Obviously, we like you to buy ours, and we feel like they're the best ones on the market. But other generators can be integrated in and be programmed to start when our batteries get low. So if there's an existing generator on a site, and it's a Kohler unit, don't shy away from the Solarc. As long as it's got that two-wire start, we can still integrate it with our batteries and with our Solarc packages.
Yeah, and I believe a lot of the Kohlers are open, normally open for that two-wire signal to start. Some of the other brands may not be normally open, but there are little adapter kits that can be leveraged to go from whatever way
Yeah,
they
you
do
can go
it to
from
the
normally open to a normally closed through a relay adapter. So
Yep.
what Daniel's pointing out is that the two-wire signal to start on the Solarc 15K is the standard normally open circuitry, and that's what we employ on Briggs and Stratton generators. There might be some generators with a two-wire start, which is a normally closed circuit, but you would need to add an adapter. Okay, sorry, I didn't want to create too much of a caveat. I did want to make sure that customers know that if they've got a generator on site other than ours, they still can add battery backup.
Yeah, Nathan, this is your Solarc, right?
Yeah, so what we're looking at here is the signal that gets sent. So right now you're seeing that there's a grid down situation and a signal is being sent to start up the generator. And so that line that's dropped down from the yellow grid means we don't have grid present. And so once that generator comes on, you can set the qualification time. I believe mine's set at 30 seconds. Once that signal from the generator qualifies, you can have that come in and cover loads. And so what you're looking at there is 2 kilowatts of load. That generator is set up to prioritize covering the loads, and that extra solar power is being used to charge the batteries there.
Yeah, great. Thank you for getting us these pictures. It gives you an idea of what it will look like, and so you can come on to it. So we're going to jump a little bit into programming. Again, we have sales application engineers on staff to help you with any of this. But the first thing on the far left is when we have a Briggs & Stratton generator, right? If a generator starts, everybody understands that a generator starts, it's going to provide power to the house. But when a generator is sitting there in standby waiting for an outage, we have to feed power to that generator. Why? Because we got to keep the starting battery in the generator itself, that little lead acid battery, on a battery tender, right? We got to keep it charged. If we have any cold weather kits in our generators, we got to keep those powered. So we're feeding power to the generator all the time. It's 240 volts. And additionally, what that generator is doing, it's looking for that presence of grid. And if you have wired up a whole home backup, or you have that power supply on the backed up loads panel, and the power goes out, well, the Solarc is going to kick over and automatically start providing backup. So the generator's still going to see the presence of grid, and we want it to, right? So we keep that battery charged, keep the cold weather kits. What we need to do is go into the GC 1031 controller on the generator and reprogram it so that if it still sees the presence of grid, go ahead and start if you get the two-wire signal to start. If you don't do this and the generator sees that two-wire signal to start, it's not going to start. So this is important to be able to get in there and change the configurations. As Nathan mentioned, I'm sure this is capable on other brands of generators as well. Nathan, do you want to talk us through the middle portion?
Yeah, sure. What we're looking at here is a Solarc 15K screen that's being shown to be programmed to charge both off of a grid source or off of a generator source. And so in the event of a grid down situation, so first to note is that when you're programming the Solarc to charge the batteries off of both, it will prioritize grid first. So that means it will not start up the generator if grid is there. It'll wait to get to that value to use the grid source as an AC charging source. However, if in a grid down situation, if we look at that setting that's there in the left column, if the battery percentage goes below 40%, what will then happen is it will send a two-wire signal to start up the generator, and once it qualifies that generator source, it will charge the batteries at up to 60 amps DC. So that's 60 amps at 50 volts approximately. So we're looking about 3,000 watts of charging. You can increase that number for our batteries all the way up to 195 amps if you've got a 3-stack of our batteries, up to the 275 amp limit on the Solarc. That's amps DC, keep that in mind.
Yeah.
So yeah, we're showing there charging both off of grid or generator. Keep in mind, it will never start up the generator if the grid is present. If you do not have grid and you're in an off-grid situation, but Solarc recommends that you put the generator on the grid port, in which case the two-wire signals to start would still come off and go to the generator to start it up. but we would be using grid charge even though it's a generator and the generator would be on the grid port. So Daniel's going to show you a little bit later on. There is a checkbox that you would want to put under the limiter tab to just let the Solarc know that you've got a generator on the grid port. But that's where we're showing the settings here. And so this is for a hybrid system in which it's a grid tied system.
Yeah, thank you, Nathan. And then on the far right is what we're looking. That's where we're going to come into that advanced tab and be able to adjust the maximum amount of watts we're going to want to pull on the generator. That's going to prevent you from overloading your generator. And so, Nathan, this one overrides the one in the middle. Is that correct?
That is correct. So if we are looking at a limit power, a generator limit power, there are a couple of things we can do. So first, we could set the generator limit power so that we don't overdraw the generator. And then we can also go into the Solarc and we can set the Solarc to prioritize loads first if we have too small of a generator. Or if we want to prioritize battery charging first, keep in mind you have to have, whatever battery charging value you set up in on that generator charge tab in the center of your screen, you have to have enough left over to cover the loads of the house. So in some cases with small generators, I would typically recommend prioritizing the load first. And then whatever extra power is left over, the inverter will use that for battery charging. So if you prioritize battery first, you might overload the generator when heavy loads start up and you could get an error message. So keep that in mind.
Yeah, thank you, Nathan. I think this is one of the keys to the Solarc's capabilities of integrating generators, is the idea that we can bring in a generator on the grid port. So what we got up in the top right corner is our grid, right? The utility, and we're bringing it into a transfer switch. And in this, normally in normal operations, this would be connected here. It would feed 200 amps into grid, 200 amps right back out. If the Solarc detects a grid outage, it's automatically going to isolate itself from grid. Notably, the transfer switch will still be connected to the grid. If for whatever reason, it's nighttime, it's cloudy, the loads are starting to deplete the batteries, and the Solarc determines that it's necessary to start the generator, it will send a 2-wire signal to start up that generator. Generator will start. Our transfer switch will recognize that the generator is started, and it will qualify it, and then it'll go ahead and transfer over. So it will automatically transfer over to that generator. And now the Solarc is going to start seeing that grid, the generator coming in on the grid port to be able to support the loads, to be able to charge the batteries. When the grid returns, the transfer switch will automatically detect that and then transfer back over to the grid power as well. And one of the things, go ahead.
You pointed that out very well, and maybe you're getting to this, but we've got solar on this system. Well, what if this system is programmed to send power back to the grid?
Well, we don't want to run a generator backwards, is what you're hinting at, Nathan. And that's, I think, speaks well to the capabilities of the Solarc. So I've heard John Cromer, one of the head trainers at Solar, kind of explain it like this: is when we have that solar, and perhaps it's a sunny day, and whatever the reason, the generator is still running, we're backfeeding the grid, right? That's what we want to do in a normal grid up situation. The Solarc is capable of recognizing the difference between the grid and a generator, right? If we're, and this is kind of, I'm going to butcher what John Cromer said, but if we're pushing against something really heavy, we don't really feel it move a lot, right? So if we're pushing back onto the grid, we're not going to see a big change in maybe the frequency or the voltage. But when we start to backfeed onto a generator, the Solarc is capable of recognizing that it's not grid, that when we push something, it's moving. And so it will recognize that and then curtail that backfeed to the grid. So that's, I think,
Absolutely.
really speaking to the capabilities.
Daniel,
go ahead.
Yeah, what you just said is exactly, what's going to happen, right? If you start to try to backfeed a generator, what's going to happen is the load on the generator comes off and the frequency on the generator will go up, right? The generator is trying to regulate that frequency to keep it right there at 60 hertz. But but it changes based on load, right? And so since it's not very stable like the grid is, it's pretty easy for the Solark to recognize with good software that hey, this is a generator, so we shouldn't be backfeeding it. So it's probing out there to make sure that it's not backfeeding a generator. The moral of the story here is that the Solark, unlike some other inverters, is smart enough not to backfeed the generator, but still allow you, once that transfer switch goes back to grid, to backfeed the grid with your excess solar. So that's a great feature.
Yeah, and I've heard John Cromer give caution to this. If you have a very large generator, that may cause some complications because then the Solark isn't going to necessarily recognize that. So reach out to either Solark or our own application engineering team if you got a large generator.
By large, we're talking about commercial grade systems, right? 200 amp, 48,000, 100,000 watts. So
yeah, anything over our air cooled generators, which stops about 26K at 26K. So another thing that's been a big topic in the industry is that now what you just saw pop up is some AC coupled solar. So we come out to a house. This is a very, I think, powerful testament to how a solar can be operated. So you come out to somebody's house that has existing grid tied solar, and they maybe didn't realize that when the power goes out, their AC coupled solar goes out, right? That grid interactive inverter is looking for grid. If it doesn't see it, it's going to shut down. UL 1741. So it's not going to want to backfeed the grid. What a solar can do, right? Definitely can have AC coupled solar. It's going to isolate itself from the grid, create that own home microgrid. And as far as those Enphase microinverters or that SMA or the Fronius or whatever you have on there is going to see the grid. Problem is if we now add a generator onto the system, we can have some complications where the AC coupled solar, and Nathan, correct me if I get any of this wrong, the AC coupled solar, in order to curtail that AC production of AC coupled solar, we have to use frequency shifting. And we kind of ramp up the frequency, I think 62 hertz, right? Those UL 1741 SB compliant inverters.
SA as well, yeah.
SA, thank you, yeah. They're going to recognize that, oh, the frequency is jumping up. Let's go ahead and stop production. But when we have a generator, the frequency of the AC bus is now being dictated by the generator. So we lose that capability of frequency shifting to curtail AC coupled solar charging. So one kind of really unique way, and there's probably other ways to do this, is
the story, right? Is you don't want them both running at the same time, right? The Solark inverter is grid following. It is being grid forming to keep the AC coupled solar on in a grid down event. But if then the batteries are depleting because the AC coupled solar is not enough, and it goes and sends that 2-hour signal to start for the generator. Now you've got the generator on, but you were keeping that AC coupled solar on in a grid down event. And so we don't want them both on at the same time. Daniel, what do we do?
Well, two things. We could put in one of our load shedding modules, which can be prioritized to, as soon as it sees the generator start, to open up and not allow that AC coupled solar to be feeding into the gen port. Another thing we could do is we could program the generator to run outside of solar hours.
So yeah, so there are two options there for that. And what Solark often recommends is programming your generator, if you do have a generator on a transfer switch and AC coupled solar, which is a fairly common situation, to program the generator only to be able to run during hours when you're not expecting AC coupled solar. Well, Briggs has got a cheaper and better solution, right? In the unlikely event that both are running at the same times, this could be an evening time where the grid is down, and your solar's there, but it's just not enough to keep up with the loads of the home. We can use one of these lockout modules, and these lockout modules are relatively inexpensive. They're something like $120, right? And then you can prevent ever having that generator and the AC coupled solar on the AC bus at the same time. So it's a really nice option that's fairly unique to Briggs and Stratton, having this ability to integrate with our transfer switch, a smart lockout module that it's a line voltage module, just takes the AC coupled solar off when that generator is on to charge the batteries.
Yeah,
Before
and
let's
these,
move on, sorry, before
yeah.
let's move on, Jim Carey comes in with a great question here. He says, as I understand, the solar converter shuts down the load when it's updating software or during maintenance issues. Is there any way to integrate a transfer switch to bypass the inverter and feed the connected loads? So Daniel, I can give you that, or I can just answer it. So the answer is absolutely. In fact, Solarc recommends that you install a 200 amp bypass transfer switch together with your Solarc to avoid these complications. Now, not everybody does it because it's about it's about $600 for a bypass transfer switch. But if you put a manual bypass transfer switch in, you can eliminate that problem, Jim. And so just look for that. It's you can look for a 3-position switch. It could be off. It could be set to the inverter, or it could be set to bypass the inverter and go straight to load. So that's backing, that's allowing the grid to pass around the Solarc inverter in the situation in which maintenance needs to be done.
Yeah, and like you mentioned, Nathan, it could be a manual. So in this example, you'd still have this transfer switch, and then you'd be connecting these guys right here, so you would be able to
You have a
bypass it as well.
secondary one after those CTs, and connecting, bypassing the inverter and going straight to that main service panel that's there. So thank you.
Yeah, and if you brought the generator into the gen port, you would only need one transfer switch. One quick thing, last comment on those Symphony 2, those also can be used as load control if you're just doing a generator. So they can be programmed to curtail loads in priorities when the generator reaches a certain load point. Lastly, we're not showing it here, but you do need to run a neutral to that Symphony 2 line module because the contactor in there is using 120 to operate that contactor as well. So we're looking at a little bit of the programming. Now we're still bringing the generator in on the grid port. Sorry. So again, this is one of the things that Nathan had mentioned earlier. If we are going to bring a gen onto the grid input, we need to be able to check that as well. One thing, again, we already covered this in the center, was programming the generator that even if it still sees the presence of grid, because it's being fed by the backed up loads out of a Solarc, to go ahead and still start as well. And then we also, again,
Daniel,
covered...
can I interrupt again?
Yeah.
We got another nice question that I'd like you to answer live here. Jean-Pierre says, do we absolutely need the grid, or can we be fully off-grid? Does Briggs & Stratton warranty our products for off-grid? Does Solarc warranty their products for off-grid?
Yes, absolutely. We do warranty our products for off-grid, both Solarc and Briggs & Stratton. So that's what's really that's what I'm really looking forward to my talk in the HYCEA is the off-grid living. And again, we absolutely can support that. And I think it would also make this situation a little bit easier in programming, because we could just bring the generator in on the grid port. We're probably not going to be worried about AC coupled solar, because I wouldn't expect to see AC coupled solar on an off-grid home.
Absolutely, Daniel. So great answer there. And I'd like to point out that both Briggs & Stratton, Simplify, and Solarc have really kind of made a name for themselves in off-grid. It's been a major part of our business history, and other backup solutions that came out later, like the Powerwall, are not suitable for off-grid. They will not be warranted for off-grid applications. So yes, absolutely, it's a big part of our business is off-grid, and we warranty for off-grid.
And I would also add that the generator, right? So there's 3 warranties: the Solarc, the hybrid inverter, the batteries, and the generator, right? Think about the warranty for the generator. Most generators, they're standby generators. They're meant for emergency usage. But we do here at Briggs & Stratton warranty our generators for off-grid use, for demand response. The terms of the warranty changed a little bit, and I think I might have a slide coming up on that. But additionally, so the third thing is the generators are also warranted for off-grid as well.
So Daniel,
yeah.
on the left side of the screen, you were getting into it before I interrupted you, but I wanted to let John know that absolutely we can do off-grid, and that's important to us. On the left side of the screen, you're looking at the grid settings in the Solarc, and you see a couple of things there. So one, you've got that checkbox for a generator connected to grid input. You want to check that box if you've got the generator connected to grid input, either because you're off grid and you have no utility, or because you have a transfer switch and you still have a generator connected to the utility there. Additionally, there's a priority setting at the bottom, and one of them says battery first and the other says load first. That's where your priority setting is for with that generator power. So if you choose battery first, it will make sure that it uses the power of the generator to meet your battery charging set points. So if you say on the right side of the screen, 60 amps of DC power goes directly to battery charging, it does that before it covers the loads of the house. So if you've got a smaller generator, we recommend prioritizing load first, and then any additional extra power that the generator can put out below the limit that you set, right? So if you set an overall limit of 10 kilowatts of power and 5 kilowatts is being used for load, it'll use that remaining 5 kilowatts for battery charging. Okay, so you make sure if you're running a small generator like a portable or a smaller unit that can barely back up the whole home, prioritize load first.
Yep, thank you, Nathan. Maybe address that zero export power there.
So the zero export power that is there on the screen, whenever you have two sources of power, like solar coming in and or generator coming in, there is the potential to send a little bit of power back the other direction, right? And it has to do with the phase of the power that's coming out. So that's the amount of tolerance, to my understanding. So I was asking SolarArc this yesterday. That's the amount of a tolerance that you're willing to accept to have power go the reverse direction. So 10 watts is not going to burn out your generator if you have solar kind of powering your loads and adding a little bit to the AC bus. So I don't know it better than that. Certainly you can reach out to SolarArc, but that's what they've let me know that's the tolerance.
Great, thank you. A couple other options you may have noticed on the charge tab is the gen exercise. So you can program the SolarArc to automatically start up the generator and exercise the generator. This can be adjusted. I would recommend, at least for the Briggs & Stratton products, is that ability to exercise itself can be handled by the generator itself. And we can adjust that. I would always recommend not adjusting the date because inevitably you're going to get homeowners that they're going to call you and says, why is my generator running? And if you change the date, and by default, they're all April's Fool's Day, and I believe later in October as well. So you don't get those calls. If you start getting 1 or 2 calls, you kind of figure out what's happening and you can let them know. So I would leave it up to the generator. Go ahead.
I've got another great question that comes in here from Jeremy Zinn. Hi, Jeremy. Welcome back to one of our trainings. Love having you on. Jeremy says, if you have a non-2-wire start generator, a 20 kilowatt Briggs that is older, I would manually turn it on the gen. I would manually turn on the gen as needed during a power outage. When this generator exercises each week, will it cause an error on the inverter when it senses the power from the generator? I'll answer that quickly, Jeremy. No, in fact, the gen port, as long as you've not told it to use it as a smart load port, the gen port will not be active at the same time as the grid port. So it can exercise the generator. It would not cause an error if you have that exercise when grid is still active. So great question. Answer is it won't cause a problem.
Yeah, and I would say also if there is a transfer switch, my understanding is that it doesn't transfer during those as well.
Yes, exactly. It will not start using the generator power. So additionally, Daniel, you're going to point out here that you can do a force gen.
Yeah.
That'll force that generator to start up. But in a grid up situation, it still won't be using that power.
Great. I think you addressed it, Nathan. Let's keep going. So keep in mind, just some other considerations here as well. You have to, and this can be done inside of our generators at least, you have to have it set in automatic mode. Additionally, to change the auto mains detect as well, which I was referring to earlier. So it does have to be in the automatic mode for that 2-wire signal to start to be able to start up that generator. We talked about how either the inverter or the generator can initiate the exercise cycle. I'd say leave it up to the generator. Generators do need to be approved for unattended operations, right? So there's some of those safety features that will shut the generator off if it's not starting. If it's not going to start, it just keeps cranking. Additionally, I would also be cautious too, and we do have a prime move or disconnect on the generators, that if you're servicing the generator or working on a generator, keep in mind that the inverter is possible to start that generator, or the generator itself, due to an exercise cycle. So just keep that in mind as caution as well. Let's jump into some of our products here. One of our exciting new products is our new stacking 6.6 battery. Each one of these modules is 6.6 kilowatt hours. So you're seeing a stack that comes in just under 20 kilowatt hours. That was intentional to meet some of the NFPA standards that it comes to building and fire codes. You can couple these up you can stack 6 of these stacks up together to get in under just 120 kilowatt hours. I like the idea of doing 2 stacks onto that 15K, because then you don't have to buy an external combiner. Like I showed you earlier, you can bring them into the dual battery lugs. I think this is a really exciting new product. Nathan and I have built a couple of these already that it goes together relatively quickly. And
I
there's
guess
no,
the other thing
yeah,
I'll say is that, I
yeah.
mean, the record of this battery system in the field is great. We're having very few issues, few issues with cables, customers, not getting the communications cables connected correctly, but excellent performance in the field. I love this battery. It goes together even on a installation wall. You'll have that battery assembled together. The only thing you have to do is your home runs and your comms cables. In 30 minutes, you'll have this up on the wall. It does come with a wall mount option. I think you're going to show that.
I thought, so this is a marketing photo on the left. I thought they did a great job. They have that gutter underneath, which kind of gives it that clean look. I know it's a marketing photo because I don't see a bunch of stickers from PV labels slapped all around the thing as well. But that's what it can look like. I think it's a great looking battery. And that does matter to homeowners. If they're going to have some battery sitting on the side of their house or sitting in their garage for the next 10, 20 years, they want something good to look at. We did show it floor mounted, but we can do a wall mount, which I think also makes it look a little cleaner and gets stuff off of the garage floor as well. All of the batteries do have status LED lights, and additionally, the controller, which is up top, also has a kind of a fuel gauge that gives a visual indication of the state of charge of the battery. A lot of people have stacking batteries. Nathan and I, you were at RE Plus almost a couple weeks ago. A lot of stacking batteries, but not everybody's stacking battery had our rapid stack connector technology, which allows you to stack the power and the communications seamlessly without having to run conductors or communication cables up the side of the battery. There's alignment pins that kind of allow you to stack it together. And we have other trainings that will come up where we dive a little deeper on exactly how these things go together as well. LFP, lithium iron phosphate, is the chemistry we leverage in standby or backup power and grid interactive batteries. Right? It's not that cobalt-based chemistries that we've seen in the industry. So lithium iron phosphate has a better cycle life. It's a little less energy dense, so it's heavier, but we don't necessarily mind, right? Because our batteries are stationary. I will say this, that Nathan and I got a chance to go check out some of Briggs Stratton other family of products, which is our Vanguard batteries, which are used in riding lawnmowers. And those are all cobalt-based chemistries, which is totally acceptable because we're looking for more energy density. We're looking for a faster discharge, but we're not scaling them up as big. Cycle life is important.
I think the point here is there is a time and place for cobalt-based chemistries, and it's not on residential battery backup, right? I mean, we believe that the LFP, for just the extra number of cycles you're going to get and the extra added safety that you're going to get on your house, is the only chemistry you want to be using in your home battery backup. Yeah, that cycle life, even compared to lead acid batteries, you're just going to get a lot longer duration. Overall, you're going to get more out of your money with LFP technology. And so we've been working that with Simplify Batteries on advancing that technology for years, making those first LFP batteries in 2010. So we do feel like we've got a lot of intellectual property on how to do this right.
Yeah.
Yes, and Fernando does point out that, hey, you're advertising less cycle life than some of our older Simplify batteries, and that is true. And part of the reason that that's true, Fernando, is that we have a very high power output out of this battery. So
let's see.
Yep, 1C. So we can bring out of the stack that you see on the left side of the screen there, can produce 14,000 watts continuously. And then with a single stack, just a single battery, just single 6.6 kilowatt hour battery, we can run that battery continuously at 6,600 watts, right? So there's a lot of power density in this compared to some of our old legacy products, I guess I will say. Daniel,
Yeah.
we just want to keep everybody on track here. We've got just 5 minutes left. So
Yeah, let's keep
through some of
going.
this.
Outdoor rated, indoor rated. You're seeing the wall mount, you're seeing the floor mount, really clean. Again, marketing photos. So I would expect you to see probably 2-inch conduit going between those two. Not the, I think that looks like 3/4 or maybe 1 inch there as well.
Yeah, if you're doing, 4-aught cabling, you could probably get away with 1.5 inch, but you really want to use a 2-inch conduit. And if you're going outside, you want to make sure that you're using something that's watertight, obviously.
Cold weather has been a big problem in this industry. We're able to go down to 14 degrees Fahrenheit on the charge cycle. If it goes, it's going to start to curtail as it gets colder. So the
This is the over
batteries,
5. So it's
yeah,
if you're charging at between 14 and 32, you're at a C over 5 rate, which means a 5-hour charge cycle, which is normally sufficient for most homeowners anyway. And then we can discharge the battery all the way down to -4 Fahrenheit, right? So if it's that cold day, you need the power and the batteries are already charged, you're good down to -4 Fahrenheit. Below -4 Fahrenheit, the battery BMS will protect itself and prevent the battery from discharging. So if you're in an extremely cold situation, there is the potential that your battery won't be able to discharge. And for that reason, we recommend, in sites where you're getting consistently low temperatures, to install indoors, potentially in a utility shed, or inside a garage, especially on an interior facing wall.
yeah,
To
because it's
get
always
those
going to have a little more heat leaking through as well.
Yeah, get those
I would also
optimal
say
conditions.
that our legacy batteries, the Fine Amplify, do have battery warmers available if you got to go outside in a cold area. But I think this is really unique for us because this allows us to put something in a relatively cold location and not waste energy by heating the battery. So it's really cool. Optimized electrolyte in the cells of our battery that let it go a little bit cooler as well. So this is the Solarc line. I know we're kind of running up on time. I just want to highlight the different lineups as well. I see a lot of people moving towards that Solarc 15K, but absolutely the 12K and the 8K can be leveraged. Solarc has also come to market with the 30K, 208, and the 60K 480. And we have generators that operate at those voltages as well. Those are our larger liquid cooled ones. Talk a little bit about that gen port that you see down there at the bottom. That's what this talk is about. So we're talking a little bit about how big of a generator you can bring into those different ports as well. We put together packages. Again, everyone's going to get a copy of this slide deck. Packages make it easy to take confusion out of the homeowner's head. And some of these hours of backup you're seeing are based on some of those average power consumption figures that Nathan had mentioned earlier in the talk as well. These are some of the legacy batteries that we've been doing, right? The Phi on the far left makes a great lead acid battery replacement. It doesn't have closed loop comms, but if you got an older piece of equipment, an old Outback, Schneider, right? You don't have comms, leverage that. Additionally, the Amplify battery is there, outdoor rated 4.9, and those are the high voltage batteries that would be used on some of the Solarc 30K and the 60K. This is the certification that I talked about earlier about our generators being warranted and certified to be used in off-grid situations, not just in that standby situation. So really excited to be able to offer all three kind of products that are available for that off-grid use. Here's the generator lineup. One thing I will call out is our NG Max, which a lot of generators that operate on, say, a 22K generator operates at 22K on propane, but as soon as you go to run it on natural gas, it derates down to maybe 18.5. With our NG Max, we're able to get all of that 22K out of a natural gas as well. Then larger air-cooled commercial. On water, liquid-cooled standby generators as well. This would be a great pairing for that 30 and 60K. I'm going to go ahead and skip ahead. We do have transfer switches. Yes, portables can be used. I'd like to see everybody put a twist lock outside, and that way you're not having to run an extension cord in. Makes it really clean and nice, and that Craftsman generator up there does have a Briggs Stratton engine in it as well. Be a little careful on these portables because sometimes they have different bonding to the frame of the generator. So look carefully in the instructions of the generator as well. Again, I'm going to skip ahead, but know where you can and cannot place the generator. One of the biggest things I see is fuel sizing, not making sure you do your fuel piping correctly on the generator. And then also making sure you get your drip leg on the fuel line as well into that generator correctly as well. I think this is worth it at least one more minute here, although we're just ran out of time. When you run a generator at a lower load point, you're not really getting the same miles per gallon out of that generator. If you can run the generator hard, run it hard, charge the generator, charge the batteries, support the loads, and then shut the generator off, you save fuel, you save the noise, and you save maintenance on the run hour. It's like driving a hybrid car. So I think that's kind of the key takeaway for everybody. I do want to thank everybody for our time. We have absolutely other training opportunities on Power Academy. Take a look. We have learn at your own pace, as well as some of these live opportunities as well. If you're here for NAPSEP, energy storage training at basco.com. That's Briggs & Stratton Company, or BASCO. Email us. We'll go ahead and get you over your NAPSEP. If you're going to be in Portland at OSEA, let Nathan and I know. If you're going to be out in Hawaii for the HICEA, let us know. We'll be happy to meet with you, sit down. Nathan, why don't we promise some gloves or some shirts, or at least something if you're able to come by the booth.
I will have some swag with me at the Oregon Solar and Battery Conference. Daniel, you're going to have some swag with you in HICEA?
Yeah, I'll be sure you get something. We even have some Lego kits. I'll just offer it now. If you come and visit us at the booth, we'll make sure you get a Lego kit as well. Nathan, any closing things for today?
I guess this, if you've got any problems when you're working on your system, we pride ourselves in our customer support. So reach out to us, 805-640-6700. Even if you don't have product yet, we've got application engineers that can help you design your system, answer your questions, and we are always happy to help. We love this stuff. So thank you for joining us today. Daniel, thank you for the excellent training. We look forward to hearing from you all. Have a good day, everyone.
Yeah, thank you, Nathan. Thank you, everyone else.